one more example of application of Kirchhoff's law, which says that in the electrical network shown in the figure, this one, use Kirchhoff's law to find the current threading through R equal to 4 ohm. So this is the given electrical network in which there is one resistance of 4 ohm through which how much current is flowing we need to find. So first of all we have to use the first law of Kirchhoff, which deals with the current. So first of all let us see the value of current, and we know that the current flows from negative to positive, negative to positive. Okay, so this is 12 volt cell, this is 6 volt cell, and one more resistance is here, which is 2 ohm, right? So from here, from negative to positive, the current will flow in this direction. For this cell, the negative to positive, the current will flow in this direction. It means that the two currents are coming like this and which is meeting at this point. Okay. Now whenever it reaches this junction, then what will happen? These currents will go in this direction. Okay. So first of all, trick is that we have to see the cells. Okay. So from this cell, which is giving current say I1, and from this cell which is giving current say I2, and here how much going? It is going I2, and here how much coming down? It is I1, and how much it is going that side? It is going I1 plus I2, of course. Okay, understood? Then how much current is threading here? This is I1 plus again I2, and this is from the Kirchhoff's junction rule. And how much current will go above? I1 current, down I2I, because from this I1 current was coming and this going, and above also it should be I1 current because this is in the same line. Similarly here also it should be I2 current. Okay, now we are done with what? We are done with the first law. Then we have to consider the loop in the second law. For that I will consider this A, B, C, D, E and F. Okay, now there are two loops. Okay, first let us consider the loop, this one. Which loop is this? This loop is like from this I will go to A. Okay, let me consider the loop in this loop, this loop. Okay, this loop. Right? So in this loop what is happening? I am going from A to E, E to F, and F to B, and B to A. Okay, so the loop, first loop we have to write loop is A, E, then there is F, then there is B, then there is A. So this is the loop. Now in the second Kirchhoff's law it says that the sum of all the potential drop and the EMF is equal to 0. So we have to find all the voltage drop and EMF in this loop, add and equal to 0. So I go from A to E, there is no cell, that is no EMF, there is no resistance, that is no voltage drop. Then I will go, so nothing to do. Now I will go from E to F. So whenever I go from E to F, there is resistance, therefore there must be the potential drop or voltage drop, that is V is equal to I into R. So I have to write I into R. How much is the current here? Current is I1 plus I2. Okay, current here is I1 into I2, and how much is the R? Is 4. So this is my 4 and I have to do plus. Now please do not solve it forward. You have to see the direction and the sign convention. Okay, please do not solve it in hurry. So for example, I will give you the sign convention. Okay, so if the direction of loop is same, okay, is same with the direction of current, then I is equal to taken as positive. Now there is loop and there is current. In loop there is always flowing current. Now if the direction of loop is same as the direction of current, then the value of current is taken as positive. So let us see here, we are going from E to F, that is the direction of loop is from E to F and the current is also going from E to F. It means both are same. Direction of loop and the direction of current is same, so the current is positive. So here I have to write positive. Okay, but since this is positive, so we don't need to write here positive. Okay, now this is done. Now let us go to FB. Whenever we go from F to B, is there any cell? No cell, no EMF, no resistance, no potential drop, nothing to do. Now I will go from B to A. Whenever I go from B to A, I find a 2 ohm resistance first. That is, there is a potential drop or voltage drop with which the equation is V equal to IR. And how much is the current here? Current is I1. So here I will write I1 into R is my 2 ohm, so that is my 2. And again I have to see the sign convention. I am going from B to A. Okay, for resistance I am going from B to A and the direction of loop is B to A. At the same time, the direction of current is from also B to A. So loop and the direction of current are same. So current is positive. So I have to write positive, but there is already positive, so I will not write. And I have to add sum of all the potential drop and EMF in closed loop is equal to 0. Now I will go to this EMF. Now for EMF, how much is the value? It is 12. Okay, and again we have to see the sign convention. So the sign convention is that we have already done in the previous lecture also. Whenever we move from negative to positive of cell, which is not required to write again and again, because the student get failed because of this sign convention. Student do not solve this. Okay, they cannot solve this. So please be very careful whenever we do the sign convention, and the sign convention is different for different author, different book. Then EMF is taken as positive. Okay, so whenever we go from first EMF only, whenever we go from negative to positive, then the EMF is taken as positive. If you see here, we are entering into negative and coming out from the positive. What does this mean? It means EMF is positive. Okay, so here is positive, and then I reached A. I started from A and I reached A, so this will be equal to 0. So let us solve this. Okay, so this will become 4I1 plus 4I2 plus 2I1 plus 12 is equal to 0, and there is 2I1 and this one. How much will become? This will become 6I1 plus 4I2 equal to minus 12. Okay, I will take this back side and I will divide it by 2, because all can be divided. If I divide it by 2, then this will become 3I1 plus 2I2 equal to minus 6, equation number 1. So for this A, E and B A loop, I got the equation 3I1 plus 2I2 equal to minus 6, equation number 1. We are done with the first. Now let us consider another loop, and this another loop is same, this loop. Okay, and we can always consider any loop. You can consider this loop, we can consider that loop. Clockwise and anti-clockwise do not matter. Again, I will start from the loop. Okay, loop. I will go to E, D, and C, and F, and E. Okay, E, D, C, F, E. So this is loop. E, D, C, F, E. This is the loop. Now, whenever I go from E to D, no EMF, no cells, no EMF, no resistance, no potential drop. Now I go from D to C, whenever I go from D to C, I get what? 6 volt EMF. So I have to write the 6 and plus. Again, I have to see the sign convention. Okay, and sign convention says if we move from positive to negative of cell. Okay, from positive to negative of cell, the EMF is negative. Okay, this is sign convention for EMF. Second sign convention. So we are going from here positive to negative. Then what should be the value of this? Going from positive to negative, EMF is negative, so it should be minus 6. Okay, so here I have to write minus 6. Sign convention are very important. Now, I will go to C to F, nothing is there, and I will go from F to E, and whenever I go from F to E, I will find a 4 ohm resistance and there is a potential drop I into R. So how much is the current? Current is I1 plus I2 into resistance is 4. Okay, again we have to see the sign convention. The sign convention says that, okay, if direction of loop is opposite with the direction of current, then current is taken as negative. Okay, if they are opposite with each other, then the value of current is negative. So if the direction of loop is opposite with the direction of current, the current is negative. So let us see the direction of loop. We are going from F to E. We started from E, B, C, F, E. So loop is EF, but the current is EF. So they are opposite. It means the current should be negative. So here I will have to write negative and within bracket in the current. Now once I go from this, I have this 4 ohm resistance and nothing is there, and I reach E. So this will be equal to 0. Nothing is here then. Let us solve this. Implies this. This is 6 plus minus minus. Okay. 4I1 plus minus minus 4I2 equal to 0. Implies this minus 4I1 minus 4I2 is equal to, okay, this is minus 6 is there, so this will become plus, okay, 6, whenever it goes there, then I will divide it by minus 2. Minus 2 से divide करेंगे तो हमको मिलेगा 2I1 here also plus 2I2 equal to minus 2 से divide करेंगे तो यहाँ minus 3 equation number 2. Okay, so we got for this is how much? We got 2I1 plus 2I2 equal to minus 3. Equation number 2. Isn't it? Yes, this. No, this will become plus. Yeah, take it, sir. Okay, fine. So this is done. Now see what I do is, I have to find the value of I1 and I have to find the value of I2. If I find I1 and I2, I will add them and I will get the current through R4. So here is I2, 2I2 and 2I2 can be eliminated. So right, subtracting equation 2 from equation 1, we get, this is class 10 mathematics. So this is plus, minus and this is minus. So plus minus cancels and this will become I1. 3 minus 2 is 1. So I1 equal to minus of 3. And so we got I1 equal to 3. Okay, this subtraction we know. And I have to find the value of I2 also and I2. Substitute the value of I1 in equation 1. What do I get? I will get 3 into, what is the value of I1? Is minus 3 plus 2I2 equal to minus 6. Okay, this will become minus 9 plus 2I2 is equal to minus 6. So 2I2 is equal to how much? This will go in. Okay, 6 plus 9. So I2 is equal to 6 by 3 by 2. Okay, this is 3 by 2, which is equal to 1.5 ampere. Okay, so I got I1 and I2. So what is I2? I2 is equal to 1.5 ampere. Now the question says find the amount of current threading through R4. Now how much is the current passing through R4? I1 and I2. So current through, we are almost done. Current through R4 is I1 plus I2. So I is this. So I will write this is equal to minus 3 plus 1.5 is equal to minus 1.5 ampere. So current through this 4 ohm resistance is minus 1.5. Again, please remember what is the signification of minus. The minus has nothing to do. For our choice, the direction of current is from E to F. This minus sign indicates that the actual direction of current which is flowing in this network is from F to E like this, not from E to F. E to F is the direction chosen by us, but F to E is the actual direction which is flowing in this network. So I got minus. So finally I have to write the I is equal to 1.5 ampere. Okay. So positive and negative is no worries.